Okay, guys, this is the first example of the day, and I want to give you this example to show you. This came from a fairly recent exam on 2017, but I wanted to show you a possibility for this exam in which they may give you information in three different ways. If you'll notice, over here we have a table that's for g of x. Over here on the right, we have a graph of a function that's for h of x. And then they give us down here f of x. So we have one equation given to us, another given to directly, another given to us as a table, and another one given to us as a graph. So the ability to understand all three of those things and what you're doing is really what they're testing here. Now let's look at now this was a non-calculator question. Obviously the exam will be calculator active, but it's a possibility that they could still give you one of these even though the question is calculator active. It doesn't necessarily mean that you are required to use a calculator. So if we look at part A, and there's another video that I've uploaded which actually goes through and solves each of these parts. I just want to kind of indicate to you what's going on with each of these. For part A, it says find the slope of the tangent line to this graph, okay? The graph of f. So that means I'll use the f function, and I got to take the derivative of this. Well, the derivative of that, guys, is going to require stuff from Chapter 2, the derivative chapter, and also Chapter 5, where we dealt with taking the derivative of e to some kind of variable. So the derivative of the cosine of 2x would be the negative sign, but chain rule says it would be negative 2 times the sine of 2x, right? Because chain rule says that 2, we have to take the derivative of what's inside. The derivative of e to some power is e to that same power. Chain rule says we have to take the derivative of that, which would be the cosine of x. And so that's the derivative, and they want us to then plug in pi. Something kind of interesting happens when you plug in pi. The answer to this is actually negative 1. Consult the other video to see how that math works out. For part B, let k of x equal h of f of x, and then you got to find k prime. Well, this is where we once again employ the chain rule. K prime of x is going to be h prime of f of x, and then f prime of x, derivative of the inside, would be f prime of x. So you're actually taking h prime of whatever this ends up being. So we'd have to plug pi in there and get a number. And then f prime of that, we actually found in part A, we found f prime of pi. So you would need to use the answer from part A into part B. Part C, once again, we're going to use the chain rule, but also this tests us on the product rule. So this is from Chapter 2 as well, 2.3, I believe, where you would do leave it alone, take the derivative, plus take the derivative, so that would be negative 2 g prime of negative 2x, leave h of x alone. And so watch the solution video on what happens when you plug 2 in there, because what you're going to have to do is if you want to find, say, h prime of 2, well, h prime of 2 would be the slope. Since this is a graph of h prime of 2 would be the slope right there, which would be negative 1/3. And h of 2 would actually be the y value there, which when you figure out using the slope what it would be there, that would actually be negative 2/3. So finding these different pieces and parts, and then of course to get g of x and g prime of x, you would have to use that table. So watch that. And then finally for part D, this comes from the mean value theorem, which I believe was in Chapter 3. Mean value theorem, is there a number on the closed interval, I want to say it was 3.2, such that g prime of c equals negative 4? Well, from negative 5 to 3, and here is g of x, there was the mean value theorem, not for integrals, but for derivatives, said if a function is a continuous function, then there's got to be a place where the average rate of change, f of b minus f of a over b minus a, equals the first derivative. So if we're looking for a place, in this case it's g prime of c, In other words, what's the slope here? Well, you would have 2 minus 10 over -3 minus -5, and so you get -8 over 2, and that reduces to -4. So you would have to justify your answer, where it says justify your answer, you would have to reference the mean value theorem and then demonstrate that you did find that number on the interval there. So anyway, guys, that is just kind of a synopsis of the different places where this comes from. You see, once again, this is a question that asks you a lot of different things. So go ahead and check this out and watch the other video to actually get the answers and see how they reference the graphs and the tables to get the values they need to get a number. Have a good day.